Hi my friends, today we model this part. It has a lot of sloped faces or tapers, and you have to be careful with them. The drawing is here. It has a basic sketch on this face as a reference for you at the beginning. We start with this sketch. New, standard millimeters IPT, XY plane, and we draw lines, vertical, sloped. We keep pressed the left button of the mouse. Now I go here and back. We have a tangency here. This point is coincident with the center point. We place on the same horizontal these 2 points. Then we apply the first dimension and we'll have another scale of the sketch all over. 21.5. Then the other dimensions, angles, this is 29. A dimension from the circle to the bottom of 53.5. This is 55. And we have a fully constrained sketch. We add some fillets of 20 between these 2 lines and also these 2 lines. Then 5 for these 2 and these 2 lines. Finished sketch. Now we apply extrude with tapers. The angles are all over 4 degrees and the thickness of this extrusion is 25. Let's do this. Extrude 25 with a taper of 4 degrees. You see now this is larger than this. Okay, you can see this by looking from the back. Yes, good. Next is this cut you see here with dimension of 17 all the way on this direction, and the depth of the extrusion is 25 minus 13. We use this face. We draw a horizontal line, dimension of 17 from the bottom, and trim left and right. Extrude, select, cut 25 minus 13. Okay. You notice that this was not with a taper anywhere. Next feature is very interesting. It is this empty volume, this one, with tapers all over. Dimensions are here. This line is parallel with this at 3 millimeters. Same here. Radius 2, this circle is equal to external circle, and 2 millimeters here, radius 2 also to the bottom. The depth of this is 25 minus 3. Let's create a sketch on this face. I draw a line with hovering on this to obtain the parallel. Then we draw a circle, then lines. This one, I hover on this to obtain the parallel, horizontal, again hover on this to obtain the other parallel. You see, we have two parallels here, two parallels here. Good. Dimensions 3 millimeters and also 3 millimeters. 2 millimeters here. We trim this and this and all the external circle, and now we make equal this circle with this circle with the same radius. Fillet 2 millimeters between these two, also here, here, and these two corners, two lines. We have a fully constrained sketch. We apply extrude of this with cut on 25 minus 3 and taper of minus 4 degrees, because this is internal, not external. Okay. You see now the result. We continue with this feature. Dimensions are 5, 17, and this dimension of 8. We'll create a plane at 48 from this face, then a rectangle with these two dimensions, and then we apply taper, extrusion with taper. Plane from this face to the left with minus 48. Then we use this for a new sketch. the sketch is a rectangle, dimensions 17, tab 5. I project this line and I make collinear these two lines. Then I place this entity or sketch in the center. This midpoint to be in the center of this yellow line. Finish sketch, extrude to the part. Yes, this means to this and to this, but we apply again 4 degrees of taper. Good. Okay, I hide this plane and we have to cut now this. It is very simple. I select a plane as a midplane of these two, then a sketch here, F7. I draw a line from this endpoint to this on the horizontal with this one. You see? Now I create a rectangle with these two corners. This means that we have a fully constrained sketch. Finish sketch, extrude this rectangle, symmetrical with cut all the way to left and right. Okay, I hide the plane and you see what we have now. Now we want to create this other volume, empty, with the ends with the center of these circles, these holes. This is why we start with creating these two holes. Dimensions are 38, hole of 6, 90 degrees. It is a countersink, a radius 6, which means diameter of 12 for this countersink. Good, we use these dimensions. Take a look here because I make something interesting. I create a sketch on this face, I draw a line with the length of 38, I place it again at the center, its center, this one to be aligned with the center of this line. on vertical. Finish sketch. Now I want to use this on the other face. To do this, I apply I forgot a dimension. This is 8.5. Now we make that trick. We select with right click this sketch and we apply redefine. Redefine on this plane. You see, we moved this here because we use countersink on this face. Countersink. This is a countersink with just the necessary dimensions. One is here and the other is here. You see? Okay. Let's apply fillet of 5 here because we have to do this. Okay. We go back to this void space with dimensions taken from here, radius 7.5 with using the centers of the holes, 10 degrees this and 10 millimeters here, and radius 1 as fillets. This is the face for a new sketch. We draw a rectangle with the other dimension of 10. Restrictions F7. On the same vertical is the midpoint with the midpoint. On the horizontal is the midpoint with other midpoint. Now I draw two circles with a radius of 7.5. They are equal. I don't apply another dimension. Then I place corners of this rectangle to the circle. Very interesting. I apply split for this segment of the circle and also this. Then I apply construction for this, this, this and this. Fillet of 1 millimeter between these two entities, other two, all corners. Finish sketch. What is the depth? The depth is the same, 3 millimeters, like here. This means that the extrusion is on 13 minus 3 with cut. Extrude this, cut 13 minus 3 and taper, my friends. Taper of minus 4 degrees, as you can see. Okay. Very good. We go further with this revolving volume, dimension 30, 40 and 8, and the chamfer of 1 at 45 degrees. Good. We use the XY plane, not XY, YZ plane, F7 and lines. The first is this one to this projection, and then up, right, down, right, and we close this contour. This is center line, 40 diameters, 40, 30 and a dimension of 8. We have a fully constrained sketch. The axis is known. Revolve with cut. OK. This hole is diameter 4.5, distance of 10 from this face, and placed on the oriented to the center point. The center point is right here. Yes, here is. Good. We cannot use the tool hole because this face is sloped or conical. This is why we use this plane, F7. We draw a circle with a diameter of 4.5 on the same vertical is this center with this center, and the distance is 10. Finish sketch. You see the circle, extrude with cut the other direction all the way through the part. Okay. Another hole is again a hole with a countersink, 90 degrees. This is 1.6. The face is sloped, so we cannot use the whole countersink, and the distance is 11. You see dimensions, so let's use again this plane for a new sketch. F7, home is here, better, and we draw a vertical line and a sloped line, and we close here. This dimension is 11. Dimension 11. The angle is 90 divided by 2. This is 1.6, and this is a center line. 2 dimensions needed. We project this line and we make coincident this line with this point. Now we are sure that we cover the dimension, and the diameter is 6. Dimension diameter 6. Finish sketch, revolve. This is what we have to revolve. Axis is known. Okay. Now we apply fillets, radius 1 on this volume, and this end. Let's do this. This is one edge. 1 is the radius, and we apply 1 to many interesting faces, plus this all around, and this. I hope I didn't miss anyone. Okay, now I see that I have a mistake here. This diameter is not 32 but 30. We use a parametric software so we can change dimensions. The last feature is this chamfer 1 at 45. I select this chamfer. 1 is already placed. Okay, let's see what is the volume. High properties, physical, update, copy, close, drawing, double click, and the new value is this one. There is a small difference, but we keep the value corresponding to our work here. We apply material aluminum ASHC and anodized light gray. If we want, we can eliminate this, and we have this nice piece. That's all for today. Thanks for watching. Bye bye.